What if I told you that our Milky Way galaxy is just a tiny speck in the vast cosmic ocean? Imagine a universe so immense that our entire galaxy, with its billions of stars, is merely a small island in an endless sea of celestial wonders. In this video, we're about to embark on a mind-bending journey beyond the familiar confines of our galactic home. From mysterious dark matter to colossal galaxy clusters, prepare to have your perception of the universe transformed forever. Imagine a cosmic city with over 100 billion twinkling lights, each one a star in our galactic home. This is our Milky Way, a vast spiral galaxy that's been our cosmic address for billions of years. But how did this celestial metropolis come to be? Our galaxy formed about 13.6 billion years ago, not long after the birth of the universe itself. In those early days, the cosmos was a chaotic place, filled with swirling clouds of gas and dark matter. But from this primordial soup, something remarkable began to take shape. Gravity, that invisible force that keeps our feet on the ground, started to pull matter together. Slowly but surely, these cosmic building blocks coalesced into the structure we now call the Milky Way. But how did order emerge from this cosmic chaos? Scientists believe it was a gradual process. As gas and dust clumped together, they began to rotate, flattening out into a disk. The densest regions collapsed under their own gravity, igniting to form the first stars. Over time, these stars grouped together, forming the spiral arms we see today. Picture our galaxy as a cosmic pinwheel. At its heart lies a dense central bulge, home to some of the oldest stars in the universe. Spiraling out from this core are majestic arms, filled with younger stars, glowing nebulae, and vast clouds of gas and dust. Surrounding it all is a spherical halo of ancient stars and mysterious dark matter. But the Milky Way is more than just stars. It's a cosmic zoo of incredible diversity. Nestled within our galaxy are countless planets, from rocky worlds like our own Earth to gas giants that dwarf Jupiter. There are glowing nebulae where new stars are born, and the remnants of long-dead stars that paint the cosmos with their final breaths. And at the very center of our galaxy lurks a supermassive black hole, a cosmic monster with the mass of millions of suns. As we gaze at the night sky, it's easy to think that this is all there is. But what lies beyond our galactic borders? The truth is, our Milky Way is just one island in a vast cosmic ocean. Beyond the edge of our galaxy lies a universe far grander than we ever imagined. Our galaxy, as immense as it seems, is just one of billions scattered throughout the observable universe. Each of these galaxies is a city of stars in its own right, with its own unique story and structure. Some are majestic spirals like our own, while others are elliptical giants or irregular dwarfs. As we prepare to leave the familiar confines of our galactic home, a whole new realm of cosmic wonders awaits us. It's time to step outside and meet our closest galactic neighbor. What secrets might it hold? How similar or different is it to our own Milky Way? These are the questions that drive astronomers to look beyond our cosmic backyard and explore the vast universe that lies just beyond our galactic horizon. Just beyond our galactic horizon lies a cosmic mirror. It reflects an image of our Milky Way, yet with subtle differences that challenge our understanding of galaxy formation. How similar is this celestial sibling to our own galaxy, and what secrets can it reveal about our cosmic past and future? Meet Andromeda, our nearest large galactic neighbor. At 2.5 million light-years away, it's the most distant object you can see with the naked eye on a clear, dark night. But how can we study something so incredibly far away? The answer lies in the incredible advancements of modern astronomy. Powerful telescopes, both on Earth and in space, have allowed us to peer across the vast cosmic gulf separating us from Andromeda. These instruments capture light that has traveled for millions of years, revealing the galaxy's structure in stunning detail. Radio telescopes detect the galaxy's gas and dust, while X-ray observatories unveil its hottest, most energetic regions. As we examine Andromeda, we find a galaxy that's both familiar and strange. Like our Milky Way, it's a grand spiral galaxy with sweeping arms filled with stars, gas, gas and dust. But Andromeda is bigger, much bigger. It spans about 220,000 light-years across, dwarfing our galaxy's 100,000 light-year diameter. Andromeda also boasts more stars, with an estimated trillion compared to our 400 billion. Yet for all its differences, Andromeda shares many similarities with our cosmic home. Both galaxies have a supermassive black hole at their center, though Andromeda's is more active, occasionally flaring up as it devours nearby stars and gas. Both are surrounded by a halo of ancient stars and mysterious dark matter, extending far beyond their visible disks. But here's where things get really interesting. Andromeda and the Milky Way are on a collision course. In about 4.5 billion years, our galaxies will begin to merge in a cosmic dance that will reshape both systems. Imagine the night sky filled with the sweeping arms of Andromeda, growing larger with each passing eon. The merger will trigger bursts of star formation, creating a spectacular light show that sadly no human will be around to witness. As mind-bending as this future collision is, it leads us to an even more intriguing question. What other galaxies are out there? The truth is, Andromeda and the Milky Way are just two members of a vastly diverse cosmic zoo. Scattered throughout the universe are galaxies of all shapes and sizes. There are elliptical galaxies, vast balls of stars with little gas or dust. Some are true giants, spanning millions of light years. Then there are irregular galaxies, cosmic oddballs with no defined shape, often the result of galactic collisions. We even find tiny dwarf galaxies, some barely larger than star clusters. Each of these galaxies tells a unique story of cosmic evolution. Some have been quietly forming stars for billions of years, while others have undergone violent collisions and mergers. Some host incredibly active black holes at their centers, blasting out jets of energy visible across the universe. Others are eerily quiet, their star formation having ceased long ago. But galaxies aren't solitary creatures drifting alone in the cosmic ocean. They have companions, and together they form some of the largest structures in the universe. What are these cosmic metropolises, and how do they shape the evolution of the galaxies within them? That's the next chapter in our cosmic journey, and it's sure to expand your perception of the universe even further. You've seen the skyline of New York City, but have you ever wondered what a celestial skyline might look like? Picture a metropolis where each skyscraper is an entire galaxy, and the streets are rivers of hot gas stretching for millions of light years. Welcome to the realm of galaxy clusters, where the laws of physics are pushed to their limits. Galaxy clusters are the largest structures in the universe held together by gravity. They're cosmic cities containing hundreds or even thousands of galaxies, all bound together in a gravitational embrace. But how do these massive structures form and evolve? The story of galaxy clusters begins in the early universe. Tiny fluctuations in the density of matter, remnants from the Big Bang, grew over time. Gravity pulled more and more material into these dense regions, eventually forming the seeds of galaxy clusters. As the universe expanded, these seeds grew, attracting nearby galaxies and gas. One of the most famous galaxy clusters is the Virgo cluster, our cosmic next-door neighbor. It's home to about 1/500 galaxies and sits at the heart of the larger Virgo supercluster, which includes our own Milky Way. Imagine looking up at a night sky filled not just with stars, but with entire galaxies, each containing billions of stars of their own. Even more impressive is the Coma cluster, a titan among galaxy clusters. Located about 321 million light-years away, it contains thousands of galaxies. At its center, two giant elliptical galaxies reign supreme, each nearly 10 times the size of our Milky Way. The space between these galaxies isn't empty. It's filled with superheated gas that's so hot it glows in X-rays. Gravity is the architect of these cosmic metropolises. It's what keeps galaxies from flying apart and maintains the overall structure of the cluster. But here's where things get really interesting. The visible matter we can see, the galaxies, stars, and gas, isn't nearly enough to explain how these clusters hold together. So what's the missing piece of this cosmic puzzle? What invisible force helps bind these clusters together? The answer lies in one of the most mysterious substances in the universe, dark matter. Dark matter doesn't emit, absorb, or reflect light, making it impossible to see directly. Yet scientists believe it makes up about 85% of the matter in the universe. In galaxy clusters, dark matter forms a vast invisible scaffolding that extends far beyond the visible galaxies. It's this dark matter that provides the extra gravitational pull needed to keep clusters intact. The discovery of dark matter's role in galaxy clusters has revolutionized our understanding of the universe. It's shown us that what we can see is just a fraction of what's out there. These cosmic cities, with their visible galaxies and invisible dark matter, are like icebergs, with most of their mass hidden from view. But even as vast and complex as galaxy clusters are, they're not the end of the story. The universe has even larger structures in store, patterns that stretch across billions of light years. What could possibly be bigger than a galaxy cluster? The answer will take us to the very limits of what we can observe in the cosmos. Just when we thought we'd reached the pinnacle of cosmic structures, the universe throws us another curveball. Beyond the majestic galaxy clusters lies a network so vast it challenges our understanding of physics. This is the realm of the cosmic web, where the largest known structures in the universe reveal themselves. But how did we discover something we can't even see? Imagine a spider's web stretching across the entire observable universe. Now picture that web made not of silk, but of countless galaxies and dark matter. This cosmic tapestry, invisible to the naked eye, holds secrets about the very birth of our universe. Scientists believe that the cosmic web is a remnant of the universe's earliest moments, a fossilized map of the primordial density fluctuations that eventually gave rise to all the structures we see today. But how did astronomers uncover this hidden structure? The answer lies in the power of modern technology and innovative thinking. By mapping the positions of millions of galaxies, scientists noticed patterns emerging on an unimaginable scale. These patterns revealed a cosmic network of filaments, nodes, and voids that span billions of light years. The filaments are like cosmic highways, streams of galaxies and dark matter that connect the densest regions of the universe. At the intersections of these filaments, we find the nodes, massive galaxy clusters that we explored earlier, and between these structures lie vast cosmic voids, enormous bubbles of near emptiness that can stretch for hundreds of millions of light years. What's truly mind-bending is how this cosmic web influences the formation and evolution of galaxies. Imagine a galaxy traveling along one of these dark matter filaments, like a car on a highway. As it moves, it gathers more material, growing in size and complexity. When it reaches a node, it might merge with other galaxies, triggering bursts of star formation. Meanwhile, galaxies in the voids lead a much quieter existence, isolated from the cosmic action. This vast network tells us something profound about the early universe. The seeds of the cosmic web were planted in the first fractions of a second after the Big Bang. Tiny quantum fluctuations, blown up to cosmic proportions by inflation, created areas of slightly higher and lower density. Over billions of years, gravity amplified these differences, eventually forming the intricate web we see today. What does this mean for our understanding of the cosmos? The cosmic web is like a time machine, allowing us to peer back to the universe's infancy. By studying its structure, we can test theories about dark matter, dark energy, and the fundamental laws of physics. It's a cosmic laboratory on an unimaginable scale. But our journey through the universe doesn't end here. As vast as the cosmic web is, it's not the final frontier of our exploration. There's one more mystery that pushes the boundaries of our understanding even further. What lies beyond the limits of what we can observe? What secrets might be hiding in the parts of the universe forever hidden from our view? These questions take us to the very edge of human knowledge, where science meets philosophy in the quest to understand our place in the cosmos. As we reach the end of our cosmic journey, it's clear that our understanding of the universe has been transformed. Our Milky Way, once thought to be the entirety of existence, is just a single thread in an incomprehensibly vast cosmic tapestry. From the familiar stars of our galaxy to the mind-bending structures of the cosmic web, we've seen that the universe is far larger and more complex than we ever imagined. But our exploration doesn't end here. For every question we've answered, a dozen more have have emerged? What other cosmic wonders are waiting to be discovered in the depths of space? Are there structures even larger than the cosmic web? And what secrets lie hidden in the parts of the universe we can't see? As we gaze up at the night sky, remember that we're part of something truly extraordinary. Our cosmic story is still unfolding, with each new discovery expanding our horizons. What will we find next in this grand cosmic adventure? Only time and our relentless curiosity will tell.